So, hi everybody and welcome back. This is C++ tutorial series for absolute beginners. This is video 174, and in this video we want to solve the exercise which I gave you in the last video. And the exercise was just simple. You should go to this site here in Stack Overflow, and there was a question: what is the difference between this? How is this in C++? That was the question from a person, and you should understand just the answer of this person here below. And he just made here an example code. So he provided here this example code, and your job was to exercise just this output here. So with other words, why we have here an output 1, 1, 2, 3. So, and his solution is here also, but the problem is to understand the solution. And why is this a problem? Because you need to know what this return value do. Then if you understand that, then you will understand this output. If not, then this output can cause confusion. And the biggest confusion is probably at this line here where you see it says one time it copies here, and one time this line with the foo return this one is again 1, but with an reference with the return this one we have a 2. So the critical point is here. If you understand this one, that's good, because that's the critical point, which means you have to understand this. So if you understand, if you understood it already, perfect. If not, don't worry, I show you the solution, and let's go into it. All right, so I copied here the code, this class, what he has. I just copied it here down to a file last time. And now when I print out, we see, yes, 1, 1, 2, and 3. And now we have to understand this. But before we understand this, let's go fast through over his class. So we make a class repetition as well. So first of all, you can see here defined a normal class called foo, public access specifier. These are all publics, but he has a private value here on the bottom, which is called value. All right. So these public specifiers are all functions, and here on top we have a constructor. How we know this? Because it is here a foo name and a foo. All right. And interesting, it is even a default constructor. How we know this, that this one is a default constructor? Because no parameters. All right, I hope this far is okay. And interesting is this one. What we have here? This one is an initializer of what we learned. This one here is this word this with the pointer means just initialize this value from this class here, which is here on the bottom with 0, which means if you construct a class of foo, then it will call this constructor, and the value here is initialized to 0 at this point. All right, so far it's easy. Next point. We start with our first function call. This one is the constructor call, but this one is the first function call active. What we have here. And for this purpose, we read now the first example here, what he is doing, before we go into that what he is doing. So, and then I will talk about the other functions here. All right, let's see what he is doing. He is creating a variable foo of the class foo, which is our type of this variable now. And like I described here, the constructor is called. The value is initialized at this point to 0 at this point here. Let's write it here a comment so we can compare this one. Write it here so that we have here the line. All right. Value is 0. All right. Then the next line. Now, he used the variable here foo, and we learned there are 2 access specifiers, one for pointers, one for normals, and you can see this is the normal access specifier, and he is calling the increment function. Where is the increment function? Must be here anywhere, and yes, it is here. And the increment function has a return type of void, which means there is no return type. But what is the increment function doing? It is using again this here, which means he is calling this one here. But here again, you could do this one as well, because then it is, what is this one here? What I did, this one is calling this one as well, and this pointer is just implicit created by the constructor, but in this case he is demonstrating it all time exactly with this one here. It's okay, so we know we can use this one to exactly say use the value here from the member, all right, and increment it. And we learned this increment as well. Plus plus means increment. It's a shortcut for value plus 1 and then assign it back to value. That is our shortcut. I hope you know this. And what happens then? After this function call, we have here what? Value equal 1. All right, so far so easy. And then what we have here, we are using again our foo variable, foo object, if you want to call it. I call it all-time variable because we are using all-time variables. All right, foo variable, and then I use again the access specifier, and this time I call the function, or he calls the function print value. All right, the print value here again, return type void, and it is just doing what? It is just taking the value again, this one here, it is taking this value and printing out. All right, so you see till now, just printed out the value which we have here at this point. Okay, we have here still value 1. All right, so far so nice. Important is here perhaps to note he is here explicitly all time pointing this value out. Normally we learned you would normally do this perhaps only if you want to distinguish between similar values. For example, if here in my I've got here a parameter value, then you would say no, print not this value out which is here in the parameter, just use the value which is here in the class. I think by now you have learned this. This is not so a big deal, I hope, so far. If not, no worry, we will repeat and do some exercise in the future videos anyway, so no worry. All right, the next line. Here we use again the foo variable which was created here, and we use all that what was called so far. So we are continue, but first foo variable here. All right, and I use again here the access specifier get copy. So we are jumping here to the function get copy. What happens here now in get copy? Function with a return type foo. All right, here we have a return type foo, and the get copy returns just the this pointer. So we learned this. What is this meaning? This is all time pointing to our class. Important emphasize here our class, and then we deferencing it, which means we are giving all our values to the return type, and the return type is a foo. So when we go here and see the foo is a type foo, that's nice, but now careful, this foo here and this foo here is not the same. That was the first tricky place. What I mean with it's not the same, the compiler actually creates here a temporarily foo object. That's the meaning of not the same. So this one is created by the compiler, which means at this point we have here our foo. After we called the, or let's say I say it creates a temporarily object. Perhaps it is other way solved, but think about this way, it's easier to understand. Then it creates this temporarily foo object, which means now we have here, actually think about it like this, we have here one foo and another foo created here. Okay, this part is tricky. Well, let me paint a little bit. So with other words, let me paint here. This is my foo, and now I create, oops, I create here a temporarily foo object. All right. Okay, this is my foo. This is my temporarily foo object. And let's see what happens. This is enough, I hope. This is just so to try to I show you something else after this one. So what happens then? So, okay, we have here created a temporarily foo object here as our return value, but what values we give us, what value we are saving to this temporarily created foo object. The values which we are saving there is from our class, because we are returning our class here as a diff reference. We are dereferencing our class and saving these values here. So what does this mean? So I said here, let's write here foo. This is the foo object, the first one. This one is the temporarily foo, temp foo. This is the second one, which is created here. And we are saving now our datas here with the return value to this one. So we are saving here our datas to this temp foo. All right, so far I hope it's okay. It's not too difficult. All right, at this point, at the end of this function, I have what I have here. I have no this, I have this one. So here I am. I have only this one. This one is right now gone. All right, so we are here. Okay, so, and then after this one, I am doing what? I am calling an increment. So first, before I call this increment, why I can call here an increment? Let's go back. This one is a foo object. All right, this is my temporarily foo object. And I give all my values to this foo object. Yes. And I am, because I am returning exactly to this point. Oops, not to this point. To this point here. Then I'm here, and when I'm here right now, I can use now again this access specifier. But important is this access specifier here, what we see here, this increment here, belongs now to this temporarily foo object, or not to foo here. So this access specifier access this one here. All right, because we are here at this point. All right. And yeah, what we have then? What we have then? That's it. Oh, wait, we have to increment, of course. So I call the increment then. That was here, because here wait a minute. Here I am. I access, and now I can call increment. All right, let's increment the value, because this foo object is also, this temporarily object is also a foo. That's why I have a increment here, and the increment is doing his job like before. It gets the value of this class, in my class, the temporarily value foo value here of this temporarily foo, and it is incrementing by 1. All right, so +1, and what is +1? What we expected is, normally you would say here +1 of this one, and you are right. You are absolutely right. So what we have here, value of temp foo equal 2. But important here is, don't make the mistake, I write here of temp foo, not of foo, of temp foo. Because at this point, let me show you this one again. Foo calls this copy here, this here. This one creates this temp. I'm here then at this point here, after this one, I have a temporarily foo, and then I use on this temp foo this increment, which means I'm still on this temp foo here of this class, which means I must write here temp foo. Temp means temporary of this foo here is 2, but when we watch it right now, this is not foo, and temp foo is not the same object. We have here 2 different objects. This one is 2, the value is here 2, but this one stays 1. Because I changed only the value of the temporarily foo, and this one is the value. Let's write this one nicer a little bit. value. This is our value, right? And here also value. All right, and let's make here. Yes, let's use this one. So you get the idea, right? And here is value, and here we have also a value. So the value here, this one is 1, this one we changed. All right, and because we copied first here, we get all the informations here to this temp foo, and then we incremented this one. Actually here not. After the increment is is this one here. I made here a bad. Oh, now I made it even worse. What I have to write is actually this one was at the increment call. Let's make an increment call as well. That's so that it's clear. Increment. All right. So, and now it's a little bit clear, right? So we create foo first. Then this foo is creating a temporary object. We call on this temporary object with this member access specifier this increment function, and this one is incrementing it by +1, but it's incrementing of this temp foo and not our foo. And because of this one here, let's read the second line, and that's a little bit the irritating part. We have here foo. When you are printing foo, then you are accessing actually this foo again here, the first one. And when you are accessing the first one foo and you are printing out the value, it's still 1 because it was here at top. It was here still 1. It was only changed, the temporarily foo value was changed, but not the foo of this object here. That's why we get here value. Oops, value 1 here, also value. Okay, value 1 here because we are here on, we are printing out this object, this here, not this one here. If we would print out this one here, this temporarily foo, then we would get here a second queue. But we are not doing this, and the reason for that is we have not saved this call here in our foo. If you would, for example, take, oops, not this one, sorry. If you would take this here, if you would, we have not saved this call here, the whole call here, in another class foo. Then if we would call their foo, then we would have a 2. And when I start now the program again, that was the reason why this number 1 1 happens, and that was the first irritating part probably, because that's that the reason for that is this kind of stuff. This here you have to understand. I don't know if it's absolute accurate explained and all right, but for understanding purposes, this one is good. If you understand this one, nice, because oops, let's go back. Because this one here, this part here, you can save it, like I said, to another foo class, and then when you save this one here, then it will print out to you. But in this case, what we have here is you are just calling it. You start with the foo class, then you call the copy, it creates this temporary foo, and then you increment this temporary foo, and then you do nothing with it. So, and that's the reason why this line here is doing just calling it, but doing nothing with the temporary class. Normally what you would do is you would then save probably this here in a foo class, or you would just anyhow save it again so to use it. Right now this line, like I said, is just for demonstration purposes, that this line is doing incrementing a temporarily, but for the first object, yeah, it's 1. Okay, if you understand this part, very nice. That was the first complicated part here, and let's go to the next part. Let's see what we have here. But before we go, let me make here some good. So, all right, so let's go here. I think that the next part is now not so difficult, because if you understand this part with this temporarily part, the other parts here are easy to understand. All right, let's get started. But you see we have here a long call. Again, how we start again? We start with the variable foo, which we have created here on top. Careful. When I say we have created on top, I mean not that the variable is not changed during the call steps here. So that's not so true what I say. I have to formalize it like this. We are using the foo object which has perhaps, which is already changed here during other calls, right? By here the calls are, for example, we have here not changed too much, but it could be changed, right? Keep this all time in mind where you get this object if there was not other operations or whatever. In this case, there is not too much changed because this one changed nothing. It just created a temporary object and throw it away again. And then it just printed out this value, which is this value, and this value is exactly the same. All right, here. Okay, we have our foo object. So I know at this point, this is the same like here on top, right? We know this. All the values are right here. So our value is 1. All right, then this time, and now what we have here, he is again access operator of this foo class, and he says get copy as reference this time. This was a get copy, but this time get copy as reference. That was in our last video where I talked, and let's see what this get copy as reference is. And look this get copy as reference looks similar like this one. The only difference, the real difference beside the name, is this foo has here no, it's a normal class, and here we have a class with as a reference. All right, so here is a little difference, right? Only this reference, and let's see what this reference is doing now. So let's start it from step, again, my picture here. I make again pictures to make it easier. But don't worry, here we are on foo. The first picture I don't need because we are using this foo here, right? And then I will make another. So get copy as a reference. Okay, we call this one, I jump, I go in, and I'm returning at this again. And we know this one is pointing to our class, and we are differencing and give all the values here to this one. What happens here? Here, at this point, we create a, if you say now a temp foo, it's wrong. At this point, we are not creating a temp foo. Why not? Because we learned already a reference, right? Reference means you create a reference to a temp foo. So we are creating a what we are creating here is a ref foo. And ref foo means I am referring to a foo object, right? We learned about references. You can only refer to an object which already exists when you are using a reference, right? And as when you are using it with a function, that's true as well. You can only refer to our object. And here, interesting is, with this return this, I'm returning my foo value where I called it. So we know it. I use the foo object, which is here, this one, and I'm returning my location as a reference here, to this reference, not as a reference, to this reference, which means I store all my values to this foo reference. Okay, what we're doing now here actually is we create a foo reference, and we are pointing. Let me show. Where is the other thing? Like, where is the? Oops, here. So now, instead of creating a foo object, like here we created a real foo object here, a temporary object, a new one. Here we are not creating an absolute new one. What we are doing is now we create a foo, which is just pointing here to our foo, right? At this, with this reference here. And here we are saying use my self location. This is my location, and you can point with your foo pointer reference or whatever you want to call it, foo reference here, to my location. All right. And now we are here at this point, which is a reference to a foo, which is here pointing to this one here. And now let's go on. That was our second step here. I hope it's a little bit clear. Don't worry, read this again in a good C++ book if you don't understand it. If you understand it, nice. And let's go on. Here at this point, I'm here again. But this time the difference is here. I'm here with a reference. I'm referencing to this one, but still I'm here, not here at the foo. I'm still here. That's why I have the type that's why I have this type here, foo reference, right? Like a variable, foo anything with a reference. All right, with that said, let's go to the next step here. Foo reference can use again an access specifier. Why I can use here an access specifier? Let's watch it. So when I have here a reference, I'm still a foo, which means a foo object, and a foo object, yes, can use as access specifier. Okay, I use here an access specifier here. This is this one, and important, this access specifier belongs still to this one here, right? Not to this one. I think this one is not accurate because we are pointing here. I have to say, let's say, so we are using it here. We are using the access specifier here, but we are a reference, right? Which means we are actually accessing here this foo this time. Next call. That's why this was not right. That's why this access specifier is just called at this point. But because we are reference, we are saying, okay, reference, go here to this object and call here on this object this increment here. All right. So what I'm doing is, then I go again to increment here. I go here, increment the value. I was 1. I increment this one here, and I become 2, which means when I call now here increment, when I call here increment, let's call it so. Also increment like old time. Increment, and the value becomes 2, but important is we have, let's write here also value, why not? Value is this time also 2. I write here also 2, but this time, because this is a reference, and the reference itself as not a location, it is using this location, which means this value here of the foo becomes 2. All right, so we can make this so that we say, okay, at this point, I see your foo value. Let's write here foo again. Foo, you are now 2. And the reason for that is because this one here, I refer to this one, I increment here on this one. And now the foo value is 2 here because of the reference here. And let's see if this is working or not. So I think I explained this a little bit bad, but yeah, read this again in the good C++ books, but I think you understand it still. And yeah, what happened is now I say at this point the value of foo is 2, right? At this point. Temp foo is here, value here, okay. And then we can go here, and this is again just printing the foo again. We are just taking here foo again, and we are printing here again the value, which is just this call here again, like all time, and we will get here value 2. All right. When I start this one, and we have indeed a 2, and the difference here, compare again, we have first a 1 that was this temporarily, that the first one was this temporarily object, which is thrown away, not used. That's why foo become in the first example still a 1. And in our case here, we have created again a reference, but this reference foo is referring to this object here, which we have created. And then it's calling its increment value here. And that's why we have here a foo 2. All right. I hope that makes sense. And then let's see what happens in the next step, the last one. So we have here again foo, and this time foo is 2 because we changed it, right? This time it's foo, not 1. Like I said, when you use an object, check the call steps if it's changed, if it's not, or just print out the values. All right, so the foo, we know it's now at this point 2, and the value of foo is now 2. We are all time referring to this value here. So, and then I use again the access specifier, and then I call get pointer. All right, let's get to the pointer. So what is the difference here? Again, look this. It looks similar like this, and like this. It's just the name again a little bit different, and of course the type. This time we have a return type of a pointer, and we are returning, here's one more thing different. This one is also different. So why we are returning here this one here? So the first answer is because this one is a pointer type. A pointer type, return type needs a pointer, and this is a pointer. We learned this at the first time when we read. This itself is a pointer. This one here is, here we are not returning a pointer. We are returning the difference operator, which means the pointed values here. So this is a little bit different, right? So what is this doing when we're returning just a pointer? Oops, what is that? Don't know. So what is this doing when we are just returning a pointer? And let's make here again, where's my paint? Let's paint a little bit again. Like all time. Okay, I try my paint again. So here I have foo, and then I think I continue here, so it will work. Then I call this get pointer. All right, let's make here again. Again here, this one. Let's call it. And here I get a pointer type, right? We have here get pointer at till this point, and we are returning a pointer type. But what means that pointer type? It's similar like this one here. We are creating a, let's write here, pointer foo. So we are creating a pointer foo here. All right, so a pointer foo. Here we created a ref foo, and here I create a pointer foo. And we learned about pointers that a pointer is pointing, right? Not all time. Sometimes when you have set it to a null pointer, it is pointing nowhere, at least not per definition. And so, but here we have a pointed value. What I mean with a pointed value, this one, this is returning a point, the value for our pointer, and this value here is what? It is our address, right? We learned that the pointer is all time the address, and the address of what? Like we learned that this is all time pointing to our class, so we are returning at this point the address of our class to this pointer. So, all right, that's cool. So let's make here. This time, this is not this is pointing here. It's because we changed already here. We called here some steps. That's why I'm here. All right, so I'm pointing to this one here. All right, good. Let's see what happens next. Okay, the pointer is pointing, and we have here something new. This time we are using the other access specifier, and we learned already that if we have a pointer type, then we are using the pointer type access specifier. So it indicates automatically when you see this kind of stuff, you are using a pointer. That's nice for programming, because when you see this one, then you know you are not using a pointer. All right, that's okay. So this one is just indicating a pointer. Let's make this time a pointer here. Okay, I point. And what I'm pointing to is to increment again. I call with the pointed member access of this foo, which is increment again. Let's see here, increment. All right, with that said, what I'm incrementing at this point first. So the pointer is pointing to the foo, which means what we learned about pointer. We learned about pointer. We are using the pointed object. And here, when we use the pointer here, we are incrementing now the pointed value of the this pointer, which is our foo, our own class. And there we call again increment. So this one refers to our class again, because we are calling, this one is calling in our class this increment. And when I'm incrementing this one, the value is what? The value becomes free, because I'm using just a pointer who is pointing to my class, and then I am incrementing it. And here important, we can see the increment says just this value again, the value where you are pointing, increment the value. And yeah, that's it, not more. So here we are just doing this one. And later in the next line here again, so let's say here is value 3. Value becomes free after this call, because we use the pointer. The pointer is pointing to our class. We call the pointer, we call the increment, but because we are pointing to our class, we call the increment of this class here, which is incrementing and setting the value to 3. And then I'm using here just a print value. And here again, I start again on my foo, which is here, but I change this value now. My foo becomes from 2 to 3. So that was before, and now we know it's 3. So the foo, let's make it one more. So that's right. This is my print value foo after the call here becomes 3. That's it. Foo, it becomes 3. Okay. All right. And let's see if this is true. I hope it is true. It is not perfect explained, but if I would explain it more in detail, for example, I want to try like this one here with more examples, but it took me roughly 2 times more time than what I spent right now. And I said, I think I should not explain it all in detail. So all the steps here in detail would take really long. So I hope you read a very good C++ book to understand this more in detail. If you haven't, because when we start now here, this one, you can see 1, 2, 3, but we can start a debugger perhaps, so that we see at least what the debugger is telling us. If I pulled anything crap or not, that's interesting. That we can do at last step here. And let's start it. So we start the debugger. So first of all, we are creating our foo. We are here at the start, but we see the type is foo here. I jump in. So it jumps here to the constructor, like I said, and the constructor is like all time here. No, this one is creating first this pointer. All right. And we have talked about this pointer here. It is created by the compiler behind the scene, and you can see it is pointing to the foo, to our object, to our class here. All right, that we know. Then we jump to our default constructor, and it sets our value is now, you can see it at this point, the value of the only value which we have, which is this one, is nothing. It's a random number. And here we set it active to anything, but I would say here that we set here default values as well. I don't know why he's not doing this, because you can see here it's a random number here on the bottom. It's not good. So here I would rather set it also to default values. All right, let's go in. And here now this value is set to 0. So far, so nice. The constructor is finished. So we have finished the first line and all expected. So let's go here to the second line. We go to foo, and foo calls here already increment. So it chooses foo increment. It jumps here on foo increment. And you can see here again, we have all time. This one is still pointing to our value here, but that's not important right now. Right now, this one is important, and the value, this value is set to what? It is incremented. No, right now it's not incremented, because right now it will be incremented when I finish this line here. I'm not finished, and now we have incremented this value. And so this value is now 1 here, this one, because this one is pointing to our member value. All right, and here we are finished with this line. Then we go to the next line, and this is just a print out. I think that's not so important. Here we are just printing out, and it is printing out that what we see later here outside. We can open up. This one is first one. All right. So now the second one, let's go into this one too. And here it jumps to the full copy. So it called the full copy here, and you can see at start it created a default constructor again. It's going here. Here it looks a little bit strange because we are here at the start. We go in, and then we make a return. And then let's see. I go here at the end, and what do we have here now? That's interesting. Where I am now. I'm here. I called foo first, then I called copy. And look what we have here on the bottom. What we have here, we have here our foo object, that is our. And here, this here, the first one, foo get copy returned. That is our temporarily copied foo. The first foo here. And in this one we are now, and let's go one step further, and now we will call on this foo copied here, this increment. And let's do this. And it's jumping here on top. And yeah, we go in. And we are incrementing the value. Look this, that was the 2 what I showed you here. That was, let me show you, I have this one, because so that you get ready. So here I explained to you that we have a foo, we make a temporarily foo copy, and this temporarily foo copy here increments the value to 2, right? That was this value, we can see it now. That is the value 2. The only difference is after this one, it is thrown away, it is not used. So we have indeed the value 2 here at the second call. With this copy here. Here I wrote also this comment value of temp foo is 2. That is exactly this 2 what we see here at this point. So that looks good. Then we go here one step further, and then now comes the interesting part. Here we calling foo, what is a little bit irritating for starters, and it is printing out thing. What is printing out? It is printing out. Have I printed this out already? It's jumping first to this print out here. All right, let's go into this one. And yeah, now interesting is here. It is this showing this one here, because this one is pointing now, not pointing. This one here is using now this foo here, what I said at the start. This one, not this temporarily object. Now we are here again. And this one, when I go into this print, it is printing out when I'm finished here. Now I'm finished. And here is the legs, and oops, where is the outprint? Here we have again a 1, right? That was the step where I said this temporarily foo is just thrown away after this one, not used. Because normally you would, when you call something like that, you would use that. In this case, he made this just for demonstration purposes, so that you can think a little bit why this is not used. All right, I hope you get this one, right? This is I think the most difficult part here, this with copy. And so let's go to the next step. The next step was our, what was it? This what time we are... I think we finished this copy one. We called now this get copy as reference, and it is jumping to get copy as reference. And you can see we have again our this, which is all time here in our clasp. And this time is doing what? It is returning, but first of all, this one is doing what here? We see nothing. We see nothing. We see only our this value here. And when I return at this point, what we have here, important is this one line again. This is the returned value of this call here after this one here. This is this line here on top, and it says type reference foo. So we have our reference, and I explained to you this one. We have made a reference to our class, which means from this point on, after this point, where is my thing here? From this point on, we can use to change our values with this reference here. All right. And we have this one here. All right, that's cool. Let's go on. We go one step further. It's calling increment with the from the reference after the reference, I mean. But it is pointing anyway to our class, right? That's why we are changing now our value. And when I'm finished with this call here, this increment call, here at start I'm foo again and printing out the value, and we can see this time it's oops. What's doing? I accidentally click anything wrong? No. I clicked anything wrong here accidentally. I have to start this fast again, sorry. But it's fast. I go just through over it. So that where we are. What's going on? I don't know. Why you do that? I don't know. My PC. Anyway, here we are again, and here the reference is created. And you can see here that was the reference to our value. That was our foo, and that was our outprint. And now we expect a 2. And when I go here into this one at this point, and you can already see this value here is 2. It changed here. All right. So the compiler is saying it works. And now let's do this with the pointer as well. We jump to the pointer. And now the pointer is creating a pointer to our class here. Return type is a pointer. But this pointer here is pointing to our class. So this variable which is created here is pointing to our class, and our class will be changed through this pointer here. Okay, and then we change the value here. First, we get the pointer here. So first of all, we created here the pointer like we created here. That was again, so point to our class. And now we call again increment here. And you see it's incremented already. I forgot to step in, but you know what increment is doing. It's just incrementing the value about our pointed value, which is our class. And we have the value 3. We can see it already here on the bottom. The value is 3. And yeah, it's pointing out 3. All right, that was the compiler version. And you can see the compiler is telling me at least you are half right. Half right means in this case you have to read this, of course, in a good C++ book or online resource where they explain all this kind of stuff perhaps more in detail if you have not understand that. And yeah, because then you understand it much more. But this one is so the core process, and the most difficult part was probably here. The most difficult part was probably to understand this copy here, because if you are not using a copy and throw it away like this line here, then it is not changing anything, and this reference and the pointer, they change if you are referring to your own class. And important perhaps also this one here, that this reference is using this difference, and a pointer is just using a pointer because we need a address, because we are creating here a pointer which is pointing to our class, and here we're creating a reference which is pointing to our class. I think if you understand these 3 parts, that's very nice. All right. With that said, I stop here this short exercise. I hope you understood this anyway. If not, no worry. We will learn this more and more, and you should, like I said, again, dive into C++ books and in online research parts to understand this more in detail. This was just more or less a practical explanation, and for our practical use case, it works. And I hope you also see how we can now call not only on references this access specifier. At this point, we can call it with pointers as well. That's also interesting. Yeah, with that said, if you have any question, any complaints, like all time, write it in the comments. See us in the next video, and yeah, have fun and don't give up like all time. Bye.